So in the last section, we saw how we were using table storage within an Azure storage account as a very simple and easy way to sort of get up and running, to create a table, store some data into it. Even Microsoft recommends a better table experience, perhaps an enterprise grade table experience using Cosmos DB. So in this section, we're going to be talking about Cosmos DB as an alternative to using a storage account. Now, Cosmos DB was recently added within the last couple of years within Azure and is meant to be, and as the name implies, built from the ground up for global distribution and the ability to scale to a very large number of transactions per second, etc. So if you're developing an application, let's say you're developing a mobile app and you're thinking that you're going to have tens of thousands, hundreds of thousands of installs, 1 million installs of your mobile app, you would not build it on an Azure storage account. You would want to use something like Cosmos DB, which is specifically designed and has certain SLAs and other guarantees for your data being available, not only locally, but around the world. It takes care of a lot of that stuff. Okay? So we're going to create our first Cosmos DB account. It's not entirely straightforward. Now we recognize this wizard that is common to creating web apps and creating virtual machines. We're going to put this in a brand new resource group, so I'm going to call it AZ Cosmos DB. And we have to create an account. So we haven't created any databases yet, similar to having a storage account that you have to then create tables for. This is a database account, and we'll have to create the databases separately. Now this database account has to be unique across all of Azure because we can see that it's fully qualified .documents.azure.com. So we're going to be referencing our Cosmos DB. If we're going to be referencing our Cosmos DB on the open web, we're going to be using a URL such as this. Now we have our first significant decision to make, and that is the type of API and the data model that we're going to use for our data. Now Cosmos DB, as we see up here, is a multi-model database service. That means that the same Cosmos DB can store data many different ways, and we get to choose as we're creating this database which way we want it to store data. Now these are NoSQL databases. That means there's no dependencies between tables. We're not going to create a master table and then a child table and then do a foreign key from the child table to the master table as you would in a relational database store. All of this Cosmos DB, again, there's no relationships that are designed to be built in. Now the consequence of that is it's going to be extremely fast. You're going to be able to query this data, and Microsoft talks about sub 10 millisecond response times, something like 5 milliseconds in order, you do a query and the data comes back to you. Very, very fast response times. Now you get your choice of API. The API you choose dictates the way that the data is stored. So for instance, if you choose the MongoDB API, then the data is going to be stored using MongoDB. Even though there's an SQL option, that's just the query API, and again, the data is stored in a NoSQL manner. We also have a table option. Graph is sort of a relationship. There is relationships in graph modes where you basically have this person is friends with that person, this person has communicated with that person, etc. You can have multiple. This is more like a social graph than anything. So just by default, we're going to start with the SQL option. And again, it's chosen Australia for some reason. I'm going to put this into Canada. Now, very interesting, again, Cosmos DB designed, even the name implies, for geo-redundancy. So by turning on geo-redundancy, it's going to duplicate my data not only in the Canada East that I chose, but it's going to put it into Canada Central. So built-in pairing between two regions, and in fact there's hundreds of miles and hundreds of kilometers between these two regions within Canada. So if there's a localized disaster in Montreal region, for instance, then when it gets into Toronto region, it should be fine. So I'm going to enable that. It's by default. And then the other option is, do I want to have data that can be written to multiple regions? So this is actually like a two-way replication where you can write to Canada East and you can write to Canada Central, and whichever you do, that it's going to be replicated properly. You can see it's disabled by default. When you start to get into stuff like this, you start to get into a little bit more complexity in terms of your applications having to have their own database homes. Maybe there's some type of conflict where the same data gets written into two places within the same, second, and then some type of data that has to be merged intelligently to try to figure out what the differences between the data, etc. So having this actually adds a little bit of complexity and the chance of data conflicts. Now, when we create our Cosmos DB account, we have to determine whether or not we want our Cosmos DB to be global or to be set onto specific virtual networks. Okay, so we can basically say, do we want it to be on no virtual network, or do we want to create a new virtual network and say only machines, applications that are running on this virtual network will have access to this. This is a security setting, and what we're going to do is just leave it as global for now. We've talked about tags when it comes to other resources. For instance, we can set our environment tag and define whether the tag goes against the entire account, which is what we're creating right now. So we can now hit the create button. Now we can see here that there is some pricing. Cosmos DBs are not free, but we're going to pay approximately 27 cents US per gigabyte per month, and it's also going to be charged based on single region rights, $6 a month for 100 RUs. And this is request units per second. So depending on how hard we're hitting this database, we're going to be charged $6 for every 100 request units per second. So over the course of a month, hopefully you're not going to use the database more than that. But you can see that the cost is basically priced as in terms of how often you use it. So if we hit the create button, we're going to have ourselves a Cosmos DB account. I'm going to pause the video and let that happen. So we can see it only took 1 minute and 3 seconds for our Cosmos DB account to be created. Let's click on the Go to Resource button. Now I'll come back to the quick start. We'll go back to the overview for a second, because we can see that since we enabled the geo-replication, it's got us in Canada East and Canada Central, and the right locations only in Canada East. I'm going to minimize this, and we can see this cool map kind of shows us where the regions of replication are. It's not that difficult to set up additional points of the world where you can replicate your data. So if you have a database, like I said, if you have a mobile app that's going to have hundreds of thousands or millions of installs, and you think, well, it would be good to have my data in North America, in South America, in Europe, in India, in China, in Australia, then you can certainly set that up. Now, China itself is, you need a separate relationship with the Chinese version of Azure for that, but Japan and other places are certainly accessible to you. Okay. Now let's go back to the quick start. We can see here Microsoft is setting us up with, we can create some basically dummy data. We can create the items collection and estimates 3 cents per hour hourly bill. It's actually pretty cool that it tells us here. So we can basically get our collection going and download a sample app to experiment with it if we wanted to go that route. Now we're going to go into the collections section. So right now we have an account. But right now we don't have any databases, nor do we have any collections, right? So we have an account, but we don't actually have anything in it. So there's sort of two layers of data within Cosmos DB. First of all, we're going to have to create a database and then put a collection inside of it. So I'm going to say add collection. So doing that brings up this add collection blade, and we have a number of values to parse out here. So first up, we have to give the database a name. Remember, there's two levels within the Cosmos DB account. That is the database and the collections. You can have multiple collections inside of a single database. So I'm going to call this main DB. This is a very generic name. Now, there is a checkbox right within here where we can basically request throughput limits onto the main database. If I click it, it opens up this throughput option at the database level, and it sets it at 50,000 request units per second. The big caveat is here, putting it at this level is going to cost us $4 per hour or $96 per day. Now this is probably going to add up to something like $2,500 to $3,000 at the end of the month. So I do not want to provision it at this level. But now that going down to a collection level, we'll get down here in a second, we can see that what it's requesting is still $20 a day. So after 30 days is still around $600. It's still not super cheap. We can reduce that. So we've given the database a name MainDB, and we're going to create the employee table. Okay, so this is the collection of data that's going to be in the Cosmos DB. Now we do need to define a partition key. The partition key, similar to storage tables, is going to be used by Cosmos DB to intelligently divide this data between servers if the data gets too big. Now, Microsoft, if you do the hover over, recommends that you choose a property that has a wide range of values and will likely be evenly distributed. So let's look at an idea where in a company, maybe you have your employees evenly split among 4 or 5 different offices. So maybe the partition key is the office, the office label, whether it's Toronto, Tokyo, New York, whatever. That could be a good partition key because then you can divide the data equally into multiple locations. The example given here is zip code. So it's another example where within the postal system in the United States, people are going to be fairly evenly distributed except for some very small limits across zip codes, right? Now, so in this case, I'm going to say job title. Now, it might not be, there's only one CEO, but for the vast majority of the company, there might be some even distribution between people who are, sales persons, customer service persons, developers, etc. This is just an example here. Now it's asking us to define the throughput at the collection level. I'm going to go for the minimum. So 400 is the minimum. And we can see here that's going to accumulate 77 cents per day, which is probably $20 at the end of the month. So there's still some fees that are going to be accumulated as soon as I click the OK button here. Finally, it's asking me to create, if I want to have unique keys. So unique keys is just as it sounds, the same with any relational database. If I say that there's I want to make sure that the employee ID is unique, then this is going to basically enforce the uniqueness of this field throughout this collection. I'm not going to end up doing that. I'm just going to click OK. So now it says creating new collection employee for database main DB. It's going to take a second to do that. And that's how long it takes. Right. So now I have a Cosmos database within this account, and there's one collection. Now, of course, there's absolutely no data in here. And we can see here that it supports triggers, the functions, stored procedures, very similar to a SQL Server database in some of those features. In the next set of videos, we're going to talk about interacting with this Cosmos DB using Visual Studio. So we have our Cosmos DB set up. We created a database called main.db, and it contains one collection called employee. Okay, what I want to do in this lesson is build a C#.NET app that is going to connect to this database and start putting data into it. Now, we're going to need a Visual Studio for this. I'm going to copy along. Remember, we used this program for the table storage. I'm going to copy the same basic structure of this and create it for Cosmos DB. Now we start off by going into NuGet Package Manager, and we're going to install a Cosmos DB package. Now in this case it's Microsoft.Azure.DocumentDB. DocumentDB is the API, this SQL API that we chose when we set up our Cosmos DB account. If we chose Mongo or we chose Cassandra or something else, you're going to choose a different package. But we're going to choose the DocumentDB package, attach it to the project, and say install. Now we're going to include at the top, I guess the key one here is this using Microsoft.Azure.Documents.Client to get that reference into the program. Now on the table storage, we sort of set up the static variables to contain the storage account, the table client, and the table itself. And we're going to do something similar with Cosmos DB. We're going to have the database name as a static variable, the collection name, and instead of having a table client, we have a document client. I also put the endpoint and the key from the storage account. If we go back to the portal and we go down to where it says keys, we can see the URI is being given to us and the primary key. Okay. Now there is this concept of a connection string, but unfortunately the Azure APIs don't just take in the connection string the way they do with table storage. You have to pass them in separately as an endpoint and a key. In the main body of the program, we just create a document client passing the endpoint and the key. So it's a lot simpler than what we have in terms of connecting to the storage account and then creating the table client as two steps. Now I've also broken out the insert and the query into separate methods like we did in the table storage. I'm going to open that up. Now you'll recall that in the table storage we created this employee entity and we just put the data as the row key. There's actually no extra properties. It just contains the partition key and the row key, and we don't have any other properties of this class. So for Cosmos DB, I'm going to open up the employee entity. I had to make a change to this. We don't have this row key, right? There's no, it's not table data. It's NoSQL. It's unstructured data. So I put the first name and last name as properties. So we got the get and the set here. And I also added this toString element. So this is going to take this object and convert it into JSON. It makes things a lot easier. So if we look at the insert op, we're going to create this entity as a new employee entity. Now I didn't create the constructor, which I could have, but instead I'm just going to set the first name and last name based on the parameters being passed. Now I have an object. Now this is the sort of the key to it here in terms of working with Cosmos DB. This create document asynchronous function takes in the database name and collection name. So remember we set these as statics. There's a create document collection URI method that will go off and create the proper name of this. And then we pass in the object. But then since this is a string, it's going to run the toString. It's going to serialize it. And because I'm calling an asynchronous method, I'm going to cheat a little bit and use the getAwaiter and then get a result in order to get the result. Because this is not a task and this is not an asynchronous method. We're doing this in a line here. Not ideal asynchronous function, but that's what we're doing in this non-asynchronous method. And so this code here will insert, I'm gonna comment out the query for a second. Simply this code here is going to insert these documents into the Cosmos DB. We've got the name John Doe, Tony Soprano, and Richard Smith. So if I was to simply start and run this program, I would, it's a console app, so it's going to look and behave much like the other app. And basically just says press any key. We haven't done the reading element to this. If I go back to Azure, there's a thing called Data Explorer that will allow us to see inside of the database. We've got our main DB database and the employee collection. And if we look at the documents inside of that collection, we have 3 documents that were found, and I'm expecting John Doe, Tony Soprano, and Richard Smith. So remember, we created the employee object that just had first name and last name. And so Cosmos DB has attached a number of things from timestamp, a unique identifier, etc., as additional fields that we didn't have to create or control. So these are basically what's being stored in Cosmos DB. It's non-structured data which is being stored as JSON. It used to be called document DB back in the day. Going back to here, now we don't have to insert. I'm going to comment out the insert commands. And let's look at the query. So now we've dealt with inserting the data. Now we want to read the data. So we're not going to be using this table query. I can actually remove it from the code. This feed options is actually a mandatory element. I was getting errors around a cross-partition query, so we had to construct these feed options. But very similar to what we did with table storage, where we had to construct a query. In the Cosmos DB, we are very similarly constructing a query. It's to create document query. We create the document collection URI just like we did for the insert with the query options. And in this case, I'm looking for the record where the last name, it says last name Jack, but we should have nobody with the last name Jack. Let's pick Mr. Soprano here, okay? So we're looking for anyone on our document that has the last name equal to Soprano. And so we're expecting 1 record to be returned. So I hit F5 and I found first name Tony, last name Soprano. Okay, so this is the document that Cosmos DB has returned, and press any key. So we can see here that building queries in Cosmos DB is very similar to building queries in table storage. Cosmos DB has the additional benefits of being a proper enterprise-grade, globally redundant system with promises in terms of service level agreements, uptime, response time, latency, etc. So we're able to use this for our real production applications in high-performance environments. Working with it, very similar to table storage. And we're just going to use the .NET functions that Microsoft provides. Now, I should also point out there are other third-party functions. We're not going to get too much into this because it's not going to be on the test. But if you were to go here and look for Cosmos DB for not installed in the browse section, then you will find that there are some pretty popular third-party things that will allow you to manage Cosmos DB. So other companies and other developers are coming up with frameworks that makes managing Cosmos DB a little bit easier. But by no means is it necessary. We can obviously do it doing the official way. All right, so that's how you develop against a Cosmos DB database. Now, another advantage of using a database like Cosmos DB is this concept of consistency. So if you go into settings under default consistency, we can see that the session consistency is the default. Now there are 5 choices to choose from. I do like this image or this animation that Microsoft has that explains what consistency looks like. So if we start on the left with strong consistency, it's basically guaranteed that when a region writes a piece of data, that all of the other replicated regions are able to read that data at the exact same moment. So in some sense, there's a delay in the writing such that the data gets replicated to all regions and then it's available to everyone. Okay, so we've got a perfect consistency across all the regions. The Canada East isn't going to read the data and be a little bit behind something that was written or another region has access to. There's a concept of bounded staleness here. And we can see that the data is going to be consistent. You see it's being deployed in the colors of the notes here are coming out in the same order. But you can define the maximum lag time. So maximum lag is here. And the note says that it is minimum of 5 seconds for a single region and 5 minutes for multiple regions, up to 1 day. So if you said, you know what, I'm okay with there being a 5-minute delay between the time that I write and the time that's available in all the regions, then you can use this bounded staleness. And we can see here the data is being written and it gets a little bit of a delay in terms of the data being available in other regions. Okay. Now session is the default, and basically what it allows is that depending on the session of the user, that person's going to get consistency. So in session A, they can write here and then read in another region, and they're going to have consistency because they're reading from the same session. Whereas another session, another client in a different region will see the same data, but basically it's going to be consistent, but there's going to be an undefined delay between each of them. Okay, so this is a little bit confusing in terms of the type of consistency model, but basically the same client, the same application could access the data in 3 regions in this case, and they'll have the same data read in A, B, and C all returns the same result, whereas a different client might get a little bit of an earlier result. Coming up next is called consistent prefix. And basically it says it's basically going to be always displayed in the right order, but we can see that there's a definite lag between the time it's written and when any particular region has it available for writing. But there is a guarantee that the data updates will always come in the right order. It's going to be A, B, ABC, but it'll never be BAC in terms of updates. Everything's guaranteed in the order, but there's really no guarantee as to when a particular region gets the next update. Now, eventual consistency is called the weakest one, and in this case, there's just no guarantee that they're going to come in the right order. So this is for the type of data where it doesn't matter what order they come in. Microsoft gives the example of retweets, likes, comments that are not in a threaded fashion. So anything where it doesn't matter that A was before B, as long as A and B eventually get displayed, then this is the kind of data model you would choose for this. So if you really do require that if you're going to write to the database and every region of the world that your database is deployed to has that data available at the exact same instant, then you're probably going to get pulled towards strong consistency. If you're fine with a little bit of a lag, some data gets written in Canada, but it takes a few seconds to get to Australia and maybe another few seconds to get to Europe, then you would choose something like this, right? Of course, you don't want the same client to read one piece of data in one database and read a different piece of data in a different database. And so maybe session consistency is best when it's bound to the client. So for the exam, it probably would be smart to review these types of consistencies and understand under what circumstances you would choose a strong consistency, what circumstances you would choose a session consistency, and maybe what circumstances are best for something like an eventual consistency where the order of the data doesn't matter as long as you have the sum total of the data, right? So hopefully that makes sense in terms of consistency, which is one option that you have for Cosmos DB that you don't have for a table storage account, for instance.